Hey, good morning, everyone. I'm Leslie Parent. I'm the Vice Dean for Research and Graduate Studies here at the Penn State College of Medicine. And I wanted to just take a couple of minutes at the beginning to welcome you and thank you for attending this workshop, which I think is going to be very, very exciting. So as biomedical and health sciences researchers, I think we're all incredibly aware of the just explosion in data that's available to us. And really the need that we have to really embrace the technology that exists to understand those data sets. And so these can include epigenetics, deep sequencing, quantitative imaging, molecular dynamics and modeling, proteomics, metabolomics, drug discovery, clinical data. I mean, the list goes on and on. And so we really embraced that here at the College of Medicine, and as part of our strategic plan that we developed a couple of years ago, we decided to begin a Center for Biomedical Informatics, AI, machine learning, because we really recognize that this is the way that science has been going and will continue to go. And as data become more complex, we really need to have the ability of more or less everyone to be able to analyze these data. So we really are excited to have a new center that focuses on informatics, and that's led by Daejong Liu, who I know you're going to be meeting during this conference. All of these things, you know, informatics, AI, neural networks, machine learning, are really going to be used, I think, to make really rapid advances in understanding biomedical research. But we can also apply it to education, health outcomes, value-based patient care, and many other areas. So Nikolai wrote me an email and asked me if I would support the idea of having a seminar like this, and I was really excited about it because I was kind of thinking that we really needed to do this for our community and for the greater community. So I was really encouraged by his offering to do this and asked him to please move forward with it. And so that's where we are for today. So I want to thank him for the vision and the rest of you for being here, and also to our speakers who are really executing this today. So we have Mike Shaw, who is an outstanding student in our MD PhD program, to thank, as well as Yan Wang, who's an assistant professor and works with Nikolai, and both of them, I think, as I understand it, have really led this today. We also want to thank Daejong Liu, who I mentioned, professor and vice chair of research in public health sciences. Elizabeth Proctor will be speaking. She's an assistant professor of neurosurgery, also in the pharmacology, bioengineering, and engineering sciences and mechanics. Vasant Hanavar, who's at the University Park campus and is Huck Chair in Biomedical Data Sciences and Artificial Intelligence. Our guest speakers will get really formal introductions, but Alexander Tropsha will be speaking, who's a distinguished professor at UNC Chapel Hill in Department of Chemical Biology and Medicinal Chemistry, and Sergei Bodyrev, who's a professor of physics at Yeshiva University. So I'll let Nikolai have the mic next, and he can tell you more about the goal for today. I think you've seen the agenda. You know it's really going to be very, very interesting, and I think take you through some of the fundamentals that need to be in place before you can apply some of these more advanced methodologies. We are recording this, so you can watch it again later. You can share it with others, and I think it'll really be a great reference for people. So to me, this is a really exciting time to be in science. The convergence of fields, including mathematics, chemistry, physics, statistics, computer modeling, biology, allow us to really look at data in a different way and really, I think, address some increasingly complex health-related problems. So I know that you all think that way as well, and so that's why you're here. So enjoy the day. Be sure to look around the campus a little bit and Hershey, and I hope that you come out of this with a really advanced understanding of informatics. So thank you.
First of all, I want to say a great thank you to people who really organized this. Is Mike Shaw. He's a really brilliant MD PhD student who has so much math and physics background that I have to constantly keep him straight, presenting to normal people about math. So that's going to be quite interesting. So that's going to be his experience to try to lay things down in a very simple terms. And I explained the mission, our mission. And Jian Wang, who is an assistant professor, who has been really truly outstanding in developing completely new types of machine learning approaches in order for drug discovery, for understanding our nutrition, how drugs interact with our body, and so on. So he's going to talk a lot about different aspects of machine learning as well. At the top of it, we have really remarkable speakers from Penn State, but also I want to highlight people from outside. Everybody will get introduction, but Sergey Buldarev, who is here, and he's in the audience, he is actually my mentor, and he is the person who really taught me a lot of statistical mechanics and fundamentals of physics. I was in particle physics, so he really is here bringing physics into the modeling here. And it's interesting, why would you say physics? Because there is a lot of phenomena that are stemming from physics that are emerging in machine learning as well. And he will talk about graphs and role of graphs in machine learning. We also have Alex Tropshak, who will show up probably tomorrow. His talk is tomorrow. And he's one of the early experts in drug discovery in QSAR modeling. So it's before machine learning, I mean before AI, I would say. And so he will give you the taste of how things were done back in the day, but also introduce new concepts like data graphs that are actually quite fascinating constructs and allow you to think about aggregating different types of data together. So besides that, there is a whole team of administrators and administrative support who really made it possible. And I can't even list names of probably 7 or 8 administrators who really were making this, are making this work. And our video crew. And so with all that, let me just tell you why we are doing this. When I was getting my PhD, I figured out, and I switched fields between high energy physics to condensed matter and then to biophysics, biochemistry. I realized that your degree is not about a particular domain of knowledge, but rather about understanding or becoming intelligent about how to learn things. So it's what really makes us understand things is how we learn, how we understand things. So understanding the knowledge is it's not the knowledge itself, but the path, how we get there. So it's really epistemology rather than the knowledge itself that is critical in order to finding things. So with advance of AI, which is and machine learning approaches, there is a lot of there is a lot of mystery and myths surrounding it. And to most of us, the AI machine learning becomes a black box that does that or this or another. And it actually creates a mystery is always a bad thing in science because it creates fear and creates misunderstanding and creates wrong interpretations of what things can and cannot do. So our role here is to demystify machine learning by giving you basically very, very rudimentary introduction is what it's all about. Starting from, you don't need to know anything except for very minimal things like how to add numbers probably, right, Mike? And a few instructions in Python, like the loops and stuff. But more than that, you don't really need to know much, and the idea is to get you from ground zero all the way to writing the first kind of code to sort of learn something using computers. So with that, I would like to give the mic to Mike so he can start, and thank you for attending.